Years ago, I noticed inside the panel of a residential home, the ground and neutral wires are tied together, as I've shown here in this graphic. And I've often wondered why you need both. So recently I watched a few YouTube videos and I just didn't like the explanations I saw, and I decided to make my own video. So here in this example on top, I show the way wiring is currently done, what meets code. And in this example, the wiring is going to a device, and I used an electric motor as an example. And the housing around the device is metal. Down below, I have another example where we skip the ground wire and instead have the metal housing tied to the neutral wire, since it's similar to what's done in practice today, where the neutral wire and the ground wire are tied together except in the panel. So let's look at what happens if you had a fault. For example, and let's start with the way it's currently done according to code. What if there was a break in the line here and the wire, the hot wire, touched the metal housing? So that would be a case where there's the probability of the wire breaking and the probability of the wire falling in such a way that it touches the metal housing. What would happen is the housing would see the full 110 volts. There'd be a surge of current going through the housing into the green ground wire, back to the panel. And with all that surge of current, the circuit breaker that the hot wire comes from would trip. Now let's look at another example. What if instead, let's put this back. What if instead there was a break in the neutral wire right here? And what if in addition that wire were to touch the housing? Well, what if this end touched the housing? Like that. Nothing would happen because you have 110 volts going to the motor, but coming out of the motor, it's open circuit, so nothing would happen. What if instead this end of the wire was the one that touched the housing? Well, there, in theory, the motor would keep running because you have 110 volts going into the motor. Coming out of the motor is 0 volts, and there's a continuous path through the ground line. But the voltage on the metal casing would be approximately 0. So it wouldn't be necessarily dangerous. If you had one of those ground fault circuit interrupt sources, it would sense a difference of current between the hot line and the neutral line, because the neutral line would have 0 and it would trip it. But if you had a regular circuit breaker, in theory, the motor would still run, but the housing would be at approximately 0. Okay, now let's look at the idea where we eliminate the ground line and instead have the neutral line also tied to the metal housing. And what if we got a break in the hot line right here, and it touched the housing, you would get the full 110 volts going through the housing, through the neutral line. The motor wouldn't be running, but you'd get a surge of current because there'd be almost no resistance, and the circuit breaker would trip, so things would remain safe. Okay, let's put that back. What if instead the neutral line broke? Let's say it broke right here. And let's say in addition to that, the wire fell in such a way that it touched the housing. Again, like the example above, the motor would actually still run because you have 110 volts going into the motor, and then coming out of the motor is 0 volts, and there's a path back to the panel. But what if instead there wasn't a break here? Let's take that away. and we're going to put this connection back. What if instead the break was just a little further downstream? What if it was right here? What would happen? Well, the motor would see 110 volts, but there'd be no path back to the panel because it's broken. So the voltage here coming into the motor is 110 volts, but because the motor's not turning and not dissipating any energy, there's no voltage drop across the motor. And so the voltage coming out of the motor would also be 110 volts. And then because it's tied to the housing would be 110 volts. And so that housing would be very dangerous. If anyone walks up and touches it at any time, you'd have an electrical shock. And by the way, I spoke before about how there's the probability of the line breaking, and in addition, the probability of the line touching the housing. Well, here, because it's automatically or already touching the housing, there is no probability of that. That's certain. So all it would take is a break in the line, and now you've got a hot metal housing, and anyone who touches it will get shocked.